Okay, so since most people, I guess, are busy with uh, the exam this week or they're busy with their exam, so what I'm going to do is not going to do a very complicated lab. So the lab is going to be rather simple. We're just kind of going to go through the code that we went through in class yesterday, um, and you can kind of play around with that during the lab. And then what I will do is at the end of the lab, um, I'm going to post some questions related to these examples. So I will share that as well. So, okay. And then maybe I'll also, assignment two, I guess, is also due. So I'll try to make an assignment related to this, um, and maybe I'll post that as well. So we have to do two more assignments. So I'll hopefully share those with you as well soon. So the first part of the lab basically is related to FIFO queues. So we're going to cover this first. Now, just one thing that I want you to remember uh, is that Python um, Q package or Q module is basically thread safe. So it is thread safe, so it kind of works rather well um, with the threading module. So you don't really have to put any locks or release locks when you're using queues, because queues generally support concurrency and they support threading. So you can basically you don't have to worry about adding locks and stuff, right? So uh, and you've kind of seen some other packages which don't support concurrency, so they end up basically being blocking functions or slowing things down. So um, some packages don't support threading, and then there are some packages that support threading but don't support async IO. So um, these are issues which I guess over time will be overcome, but for now, these are things that you have to kind of uh, do give some thought to. But the good thing about the Q package is that it is thread safe. Okay. So that's why when we're using the queue, we can just import it and not add any logs or anything to it. Okay, so let's take a look at this code that we discussed in class yesterday. So we kind of defined this function called mySubscriber, and what this function basically does is that it takes a queue as an input, and then it sees that okay, if the queue is not empty, it basically gets an item from the queue. And so by getting an item, what we are essentially doing is that we're removing the item from the queue. So we basically get um, whatever is up next, or whatever item is up next, or whatever object is basically at the top of the queue. We basically remove that and put that in the item object here. Now, if the item is none, so if there is nothing in the item, which probably is happens because of the queue being empty, what we do is we just break out of this function and go back to the calling function. But if it's not empty, what we do is we just go ahead and we print that, okay, uh, so and so thread. So we basically print the current thread. So whatever thread basically called my subscriber. So okay, this thread removed this item. So we print the name of the item, and we print the name of the thread that removed the item from the queue. And then we just use this task done function to kind of indicate that, okay, um, this particular task in the queue is done. And um, just to kind of simulate a little bit of a delay, we then make the thread go to sleep for 1 second. And the reason we're doing that is because we kind of want the other threads to come in and remove items from the queue. I mean, you don't have to do it, but um, what may end up happening if you don't go to sleep is that just one thread may just remove everything from the queue, which is fine, but then it won't really explain how multiple threads would be working here. So that's why we just introduce this synthetic or artificial delay here. So hopefully the next thread comes along and that kind of gets a chance to remove something from the queue. Okay. um, so this is basically our kind of function that we're using, and then we haven't really put the rest of the stuff inside a main module or a main function. We could have done that, um, but you don't have to. I mean, you could just write these things line by line and that would still work. So the first thing we do is we basically create a queue object, and we generally, the way to create it is to um, use the queue method from the class or the queue module, right? Um, and by default, this is going to be a LIFO, uh, sorry, this is going to be a FIFO queue. So it doesn't really say FIFO queue, but if you look at the documentation, what you will realize is that this will be a FIFO queue, okay? And you may want to note these things down because I may ask these later in the lab question, right? Um, so this is a queue, and so my queue, so queue.queue will basically return a FIFO queue, right? So if it doesn't say the type of queue, then that means that you're talking about the FIFO queue. Okay, so this will return the FIFO queue. You can even look at the documentation for this. Um, queue dot okay, sorry, you don't see that part of my screen. Let me reshare. So, so if you look at the Python documentation, you can see that queue.queue basically is a constructor for a FIFO queue, right? So even though it does not say FIFO queue here in the name, but this basically is going to give you a FIFO queue. So what is a FIFO queue? FIFO queue is basically a first in, first out queue. Okay, so whatever goes in first comes up first. All right. Now let me go back to the Python part. Okay. So we create the FIFO queue here, and then after we create the queue object, what we do is we just put like integers from 0 to 9 into the queue. So we just basically write a loop, and inside that loop we just put the loop index using the myQueue.put method. We put um, the um, the loop index into the queue. So initially the queue is empty, you get an empty queue, and then you add the integers from 0 to 9 into that FIFO queue. And then once that's done, you basically just tell the user, okay, the queue has been populated. Once it's populated, then you basically create this empty list for threads. And then once you have the threads, um, the next thing that you do is um, you basically start a loop from which ranges from 0 to 3, right? So 0, 1, 2, and 3. So you're basically going to create 4 threads: thread 0, thread 1, thread 2, and thread 3. Uh, and each thread basically what it will do is it will apply this target function. The target function is my subscriber, and the argument for that target function will just be my queue. So the queue object that you have. So what you're going to do is you're going to take the target function for each thread. What it does is it takes the target function and applies that target function to my queue. And what does the target function do? The target function basically just goes in, removes the item that is up for removal, right? Um, and then it goes to sleep for 1 second, and then it wakes up again after 1 second, and then it sees if there are any more items that are to be removed from the queue. It basically goes ahead and removes them and then prints the message that, okay, I removed this item from the queue, and then it again goes to sleep for 1 second. So you keep doing that. Um, and so you start these threads, um, and then finally what you do is you make the program wait for the threads as well. So you start them, but you also want the program to wait for each thread to kind of complete. So don't just start the threads and then move on. You want the program to wait for each thread to complete. um, and then finally, once all threads have completed, you print the message that queue is empty. So that's all that's going to happen in this function. Okay, so let's run this program and then see what happens, right? So remember, we're going to put 0 in the queue first, 1, 2, 3, 4, 5, up to 9. Now, this is a FIFO queue. So which item is going to get removed first? What item are we going to get if we basically try to get something from the queue, given the knowledge that this is a FIFO queue? Anybody would like to answer? So we have the integers from 0 to 9 that get put on the queue, with 0 being put on the queue first and 9 being put into the queue last. So which number would get removed from the queue first? Would it be 0 or would it be 9? Yes, thank you. So yeah, it would be 0 because this is a FIFO queue, right? So first in, first out. Okay, so whichever thread basically gets started first, and I think thread 0 gets started first. So thread 0 will basically go ahead and remove um, 0. Thread 1 will go ahead and remove 1, and then you go up to thread 3, and then all the 3 threads go to sleep, and then whichever one wakes up first, it will remove the next number. So let's go ahead and give that a run and see if um, what we were thinking was correct. Okay, so once I run this, so thread 7, okay, so don't worry about the thread numbers because Python kind of remembers previous threads, numbers of previous threads, so it may not start from 0. But our first thread seems to be thread number 7. So thread number 7 removes 0 from the queue, right? So 0 gets removed first. Then the next thread, which is thread number 8, it basically removes 1 from the queue. Thread 9 removes 2 from the queue. Thread 10 removes 3 from the queue, right? So we have 4 threads, so 7, 8, 9, and 10. And they go to sleep, and then I guess thread 8 wakes up first. Removes 4 from the queue. Then thread 10 wakes up. It removes 5 from the queue. Then thread 7 wakes up, removes 6 from the queue, and then thread 9 wakes up and it removes 7 from the queue. And so you kind of keep going until you remove the last item from the queue, which was 9. And once that is removed, then you get this message queue is empty, right? But notice that because this was first in, first out queue, so you get this message where you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you basically have first in, first out. That's the order in which items are removed from the queue. No, in this case, the order is not really that important. I mean, just using the threads, we don't really care which thread um, removes or which thread basically wakes up first. I mean, as long as, because the threads are kind of doing the same task, so we don't really care about which one uh, wakes up first or which one does what. Okay, not in this example at least. Okay, so this was the FIFO queue. Now let's look at the LIFO queue. Now with the LIFO queue, the program is basically identical. And the only change when I switch tabs, you can see is the only change that I make is I just use the LIFO queue method to create my queue, right? So in this case, I was just using q.queue. So that gave me a FIFO queue. And then if I write q.LIFO queue, I basically create a LIFO queue. So last in, first out. So in this case, the order in which you will proceed is going to be reversed. So 9 is going to get removed first, then 8, and then 7, and then 0 is going to get removed last, right? But as far as the threads are concerned, how they're created and how they're managed, what the target function is, everything else is basically pretty much the same. So let's go ahead and start this one and then see what this does. And you can see that 9 gets removed first, right? Because this was LIFO queue. And then 8 and 7 uh, and then you basically go into this 0 basically is removed at the very end. Why? And the reason for this was that we were basically using a LIFO queue, not a FIFO queue, right? So last in, first out. So last in was 9, and so 9 basically is dequeued first. Okay, so this should be fairly straightforward. So there's nothing really complex about this. It's pretty simple, straightforward to do. And then the next part that I kind of want to do is the priority queue. So with the priority queue, one difference that you make, of course, is that you use the q.priority queue method, right? So with the priority queue, what will happen is you can assign priorities to your tasks, right? Or to your items. So whatever items you're putting in the queue, you can assign them a priority. So so the first argument that you give basically is the priority. So whenever you're kind of looking at the priority queue, the put method for the priority queue basically has you need to supply two arguments. You first need to supply the priority, and then the second argument basically is the item that you're basically going to put onto the queue. So now, as far as priority is concerned, the lower the number of priority, the higher the priority that the item is going to receive, right? So 0 will have the lowest priority. You can even look at the documentation of this. Let me see if I can show you this on Python. So just give me 1 second. Um, okay, share that. Okay, so you can see you have the q.priority queue here, right? So this is the constructor for priority queue. Um, and then inside the arguments, a typical form of entry is a tuple of the form. So this is your priority number. And then the next part is the data that you want to put onto the queue. So the priority number basically indicates, um, you know, how much priority do you want to assign to the data that you're putting onto the queue. Now, let me see if there is more details about the priority number. Uh, so doesn't really specify, but you kind of see, right, the lowest valued entries are retrieved first. So lowest value entry is the one returned by the sorted list. So typical, and yeah, so I guess you basically can assign it. Um, so the lower the value you assign to priority number, the higher the priority it's going to get. Now, this sounds a little counterintuitive, because if you want to give a high priority, you may want to give like a high number, but in this case, you assign a low priority, and assigning a low number to priority, a low value to the priority number gives a high priority, right? So 0 would have the highest priority. and 10 would have, like, if you're just using the integers from 0 to 10, then 10 would have the lowest priority. So you could think of priority number as maybe something like service speed or something. So the the item or the data that has the lowest value for the service speed or service requirement, that means that it requires the quickest service, right? So rather than thinking of this as priority number, this could be thought of as, like, um, uh, expected wait time or whatever, or the amount of patience that this data has. So if it's zero, that you kind of need to kind of service this first. Okay. Um, okay. So let's go back to Python. Right. So what do we have here? So this is one more difference from the previous program. So we basically have the loop again. The loop it ranges from 0 to 4, and then we basically put uh, the loop number or the loop index. So that basically is the priority number. So the first index of the loop is going to be 0. And so 0 is going to get a priority. So 0 is going to be your priority, and then the data that is put onto the queue will also be 0. So 0 will have the highest priority. Then you will have 1, which will have the second highest priority, then 2, then 3, and then 4. And you repeat this loop 2 times. So you kind of put zeros with the highest priority, and then 1, and then 2, and then 3, and then 4. 4 will have the lowest priority, and then again you repeat the same pattern. So you have 5 items on your priority queue. Those 5 items are the integers 0 to 4, and then the lower integers will have the higher priority, right? So you have 0, 1, 2, 3, 4, and then 0, 1, 2, 3, 4 again. So um, these 5 items in the priority queue. Okay. And then once that is done, so your queue is populated, then what you do is you basically create 2 threads. Now in this case, we're using 2 threads um, just to kind of illustrate the problem. If you use more than 2 threads, then you won't really see the reason or you won't really appreciate the use of a priority queue here. So that's why we're just using 2 threads here. So we create 2 threads. Again, we give them the mySubscriber function as the target. The function is pretty much the same. No differences in the function. The argument is basically the myQueue object. You start the thread. You put the threads inside a list of threads, and then you basically run another loop through this list of threads, and you want them, just want the program to kind of wait for each thread before moving on, right? So that's the only purpose of this particular loop here. So you just want to wait for each thread to complete before you proceed and tell the user that the queue is empty. Okay. Now, what do you think is going to happen in this priority queue? What item is going to get popped first? Think about it for a second. Let me show you this thing in the form of a table so you kind of know exactly what it looks like. Just give me 1 second. Okay, so this is what your queue looks like right now, right? So you have the first item that was put into the queue was 0, had the priority 0, so it has the highest priority, and then uh, 1, 2, 3, and 4, and then 0 again, right? So what's the first item that is going to get removed from the queue? If a thread comes in and it sees this queue, um, the function is going to get an item for that thread, and that thread item is going to get removed. So which item is going to get removed first? Can anybody tell me? Again, this is a priority queue, and the items that have a lower number assigned as priority will get the highest priority. So which one do you think will get removed first? Okay, looks like people have gone to sleep. Tell you. Um, so obviously this one is going to get removed first, right? So once this guy is removed, so if I remove this one, um, now next time when you come around into this queue, which is the next item that's going to get removed? Is it going to be this one or something else? Right, so the next item that will get removed is basically this guy here, right? Because if you look at the whole the whole list of items in the priority queue, you can see that this one has the lowest priority number, so it gets the highest priority. So this item, even though it's not really on the top of the queue, will get removed next. And then one item with one priority will get removed, and then so on and so forth. Okay. So that's basically how this priority queue should work. So let's go ahead and run the code and see whether this actually happens. So let me go ahead and run this. Share my Python window. Okay, so now when I run this program, so this is the priority queue program that I ran, right? And you can see that the first thread removed 0 from the queue, and then the second thread, even though 0 was not, you could say, not put in first or last onto the queue, it's right in the middle. We removed 0 from the queue because it has the highest priority, right? And then the two ones that are on the queue get removed, and then the two twos get removed, and then the two threes get removed, and then the two fours get removed, and then finally the queue is empty, right? And that's basically because we had the priority queue doing that work according to a specific priority. Okay, so I hope this makes sense. I'll just kind of create a folder uh, into the content um, link or the content directory, and I'll upload this code for Lab06. And I think that's enough in terms of the lecture. Now what I'll do is work on some questions for you, so you can play around with this code in the meantime. There's another program that I'd like you to look at. I'm not going to discuss it, but this basically, what this program does is it kind of evaluates prime numbers based on um, using concurrency. So it uses threads to kind of print factors rather, not prime numbers, so factors of numbers. So it will take this input, pass one input at a time to one thread. So you have, I think, multiple threads working here. You have three threads. Each thread will take one number at a time, and it will show you the integer multiples, if any, of that of the input number, and it'll kind of show you what the multiples of uh, that particular number are. Okay, so I guess you could play around with this program as well and try to understand how threading works here, and how the queue is also used here. So this is a slightly different example, and it uses a specific queue. Now, what type of a queue is this? This is the FIFO queue. Okay, so take a look at this, and the other programs. Play around with them. Feel free to make changes with them, and then hopefully within the next hour or so, I will create the lab questions and I will upload those, and then you can attempt those. And enter the answers before the deadline, which will be tomorrow night. Okay, but it's not going to be that complicated, so it's going to be pretty much simple to do. So just go ahead and do those questions whenever you have time, but do submit them before the deadline. Okay, so that's it. All right, guys. So I'll see you in class tomorrow, inshallah. But I am going to be online, so I am going to be online for the rest of the lab. So if you want to ask me questions, I am available. Okay. Also, don't leave because then your attendance may not get marked. So just stick around and work on the lab. In the meantime, let me just quickly upload the code, so you can kind of copy paste it from there rather than writing it yourself. So I'm going to kind of do that right now. So okay, so you have the code in the folder for Lab 6. So please, feel free to download the code and play around with it. Okay, and then I'm available if you have any questions.